What's up, YouTube? How's everybody doing out there? This is Greg from GregsTutoringNYC at gmail.com. Hopefully everybody's all right. So this has been a very strange year between remote learning, pandemics, confusion, lots of different things happening in the world today. Elections, protests, quite an interesting year. In past years, I never really did a BCA live stream. And with the New York City SHSAT being postponed and the Hunter High School test up in the air as well as state tests and a whole bunch of other things, I figured let me do a twirl and give the Bergen County Academies admissions exam a little attention here. I've tutored kids on it in the past, and it's an interesting test in its own right. On the same note, there's an overlap between a lot of different tests. Some ways the Bergen County Academy is easier than some, and in some ways it's harder. So depending on which test we're looking at. So if you're taking a different test, this stream probably will still help you. You may look at some examples and say that's too easy, and other ones might be a challenge for you. So with that in mind, just tell you guys a little bit about me, because even though some of the New York City people know about me, maybe the New Jersey people don't know as much. A New York City-based tutor. Been tutoring for a really long time. I help some of you guys out on Reddit and also through email and other things as well. I have hundreds of hours of live streams already on YouTube that are appropriate for BCA, for admissions tests. There's even some, if you look through them, you'll find references to BCA. So I pulled some examples here and there, also did some other things. So I see a few people out there. Howdy, how's everybody doing? Please like, please subscribe. I'm not sure how many of these are going to do, but I'm going to do a few, maybe one a week. So what we're going to do today is the practice test. Some of you guys have the sample that's on the screen. Let me find out a link for that for anybody who doesn't. Give me 1 second. I'll put the link in the chat. And that's the PDF file I'm using. It has the sample questions that BCA themselves is suggesting. This is directly from them. So theoretically, that's normally considered the best source to get information from. Not always, though. You have to remember that whoever's writing the test and providing samples, they're not going to give you every single question, because then you can start gaming it and so on. You have a whole bunch of topics in math. Most of the BCA test is math focused, and you do have a writing section based on a passage. We're not going to talk about that today, but at some point I can do that for you guys. Anyway, the math is basically up until your grade 8 math. So it's all the math you learned up until now. It has a little bit of geometry, a little bit of trigonometry, but it's mainly arithmetic based and algebra based. Okay, and the algebra is not super advanced algebra. It's not really going to go into high school algebra. So what it's really looking for you is to be proficient and completely master up until 8th grade math. Okay, and on the ELA as well, but the ELA is just one part. And then there's a whole bunch of other parts during the admission process, including your essay, the interview, your New Jersey state test scores, and a whole bunch of things go into your application process. So currently, BCA is saying that your test is going to happen early January. If you don't know, the date's already there. I think, popping this out of my head, I think your deadline is December 5th to apply. I could have that wrong. So don't depend on that part of things from me. Definitely go on to the BCA site and check that out. Originating through the bergen.org or the BCA-admissions. Same as the beginning of the link I put down for the PDF of this file. So the point is that these problems are really just a representational sample. Okay, so you need to do above and beyond that. They're not going to give you everything. There's maybe there's 15 times 7, so it's 105. Plus, I think there's an extra one here with 40. So there's about 135 questions on this PDF pertaining to the math. And technically, they can ask you thousands, tens of thousands, even hundreds of thousands of possible questions. Because even if it's on a certain topic, it might be about exponents, Is it about exponent addition, exponent multiplication, exponent division, and even let's just say it's about exponent multiplication. They can tweak that in so many different ways. So there's just thousands of possible questions they can ask you. And of course, on test day, there's only a few dozen questions that basically you have to answer within an hour. So I want to kind of stay away from the details of how the test actually works and so on. But let's just cover one detail for now. So on your screen, you should see me and the Bergen County thing there. I'm going to flip into the actual beginning of the test, which is what they're providing in the sample. Whether this will follow on test day or not is unclear. But if you notice, it says that there's no calculator. You have 1 hour to answer 40 questions. So basically, that's your first math problem. It means you have to answer the questions pretty fast, within a minute and a half each. Okay? There's also a slight gotcha there. It says 2 points are given for each correct answer, and a half a point is deducted for each incorrect answer. So there's a penalty. Okay? What you need to do is go find out and make sure that's how it's going to work this year, because this is going to be based on part of your strategy on top of just answering the raw math and the raw ELA. It's important to know how scoring works, because it's not just, oh, I don't know 20 of these, let me just answer them. It means you're going to lose 5 points by doing that. So depending on your proficiency or lack thereof, it may be worth your while to not even answer a question. This is also your strategy as you go through the test, where you want to take what I call the easy test first, which is the ones you know you can absolutely answer, so that the ones left over you can either leave blank, or at that point, when you're doing the double checking or whatever the case may be, then you're going to make a calculated decision. Do I answer this or not? Okay? So most of the choices have 4 choices. Means you have a 25% chance for each answer. If you can rule one out, you went to 33%. So you want to weigh that against the half a point deduction, right? Because if each one's worth 2 points, 25% of that is half a point. So if you can rule out one answer, you're even. If you can rule out 2 answers, it's worth you taking the shot on trying to get the answer out of there. All right? So hopefully that makes sense to everybody. All right, so some people are hanging out there. I see the numbers going up and down. So howdy again, everybody. I'm Greg from Greg's Tutoring. So what I'm going to do now is just start jumping into the problems. And like I said, we'll start doing these. So I'm all the way down into the sample.pdf file at practice problems number 1. I'm not sure how they oriented this or why they oriented one at the very bottom, but that's where we're going to start from. So what I'm going to do is turn on I have another camera here. And like I said, this applies to other tests. This does not just apply to the BCA. A lot of tests for high school admissions are kind of at the same level here. Let me get a blank piece of paper. I also printed this out because it might be handy for some of the problems to actually do it on the test paper itself, especially if there's geometry or something involved. So some of these are testing you. So the first question is, how many positive factors, including 1 and itself, does 72 have? All right. And just give me 1 second. I gotta make sure this thing is live. Okay, it seems to be. So really what we're gonna do is, instead of listing them down, we're gonna do factor pairs. We have 172, 236, okay, 324. A lot of kids don't realize that one. Okay, 4, and we can divide this in half twice, right? Division by 4 means divide this in half, we get 36. Divide it in half again, we get 18. Right? We can multiply that. 40 plus 32 is 72. 5 is no good. 6 goes in here 12 times. A lot of kids skip that one as well. Okay, 7 is no good. And then you have 8 and 9. Okay? So how many factors are there? 2, 4, 6, 8, 10. And it says including the first set here. All right? So we have to include that. So we get 12. All right? So that's the answer to the first one. In fact, I have multiple screens up, so let me actually get the page that this problem is on, so that I can look at the paper copy as we're going along as well. Okay, so one would be E. Okay, the second problem is if the sides of a square, and I'll scroll this as we go along. If the sides of a square are increased by 20%, by what percentage does the area of the square increase? So a lot of you are going to do either 20 plus 20 or 20 times 20 and kind of see that D leap out at you. But the problem with that is that if we have the square, let's say it's a 5 by 5, and we increase it by 20%, 20% of 5 is 1. So we're going to make it a 6 by 6. Okay? If you do the 20 by 20, you're losing that little unit right there. Okay? So that's why D is no good. Okay? So what we learn is that we have 1.2 of x. If a side is x, we have 1.2 of x. So area of a square equals the side squared. So we have 1.2 squared. And that's equal to 12 times 12, right? We got 144. And we're going to have 1.2 times 1.2. So we're going to have 2 decimal places. And we get 1.44. So just the same way we did 1.2 here, it's 20% higher. We're 44% higher over here as well. All right? We could also plug in numbers here if you want. Let's say it was a 5 by 5 and we change it to 6 by 6. We could do 36 minus 25. That's the two areas over the original area. Okay? And that gives us 11 over 25. And that is also 0.44, because that's the same as 44 over 100. All right? And let me just pop in here and see if any comments. Nope. There's 2 viewers. Hello. Please feel free to chime in. You can guess the answers. And by the way, if you're catching us the replay, you can pause the video, try to figure out the answer yourself, and then go back into it. All right? So I'm just going to go here for about 45 minutes or an hour. If we finish the 15 questions in the sample before that, cool. If not, we'll do a part 2. Like I said, I'm not sure what my schedule really is here of doing these. So, but at the moment, I plan on doing maybe 1 a week. That way we can move, if there's 7 or 8 samples from Bergen, that's 8 weeks. So that's all through November, all through December. And then there's 2 or 3 extra weeks until the actual test date that we can figure out some other stuff. And I'll probably throw some stuff in the middle of it, either directly related to BCA or not directly related to BCA. Okay? All right. So let's go to question number 3. Question number 3 is a harder one. Okay? And by the way, I'm going to move my camera slightly to give us more space to see what they are. Because I realize the page is getting cut off slightly. Okay, some of you may have never seen, so whereas one was like, that's too easy, some of you probably never have seen a question like number 3 before. One reason is because it's usually something in the latter part of grade 8 and sometimes even in grade 9. Okay? Some of you are taking high school algebra in middle school. So some of you may have seen this yet. Or because the school year is remote and remote learning is not as good as in-person learning, you may never even get up to it this year. Okay? So what we want to do is approach this through algebra, and we want to approach this problem logically. All right? There's 2 levels to it. So what we're going to do is write out 2 symbolic equations and then try to make sense of them together as a combined unit. All right? So he has 25 questions on his test. For each answer he got right, he gets 4 points. So I break down math problems per sentence, and within a sentence I break it down per phrase. So Jeff answered all 25 questions on his chemistry question. Cool. What's the deal here? This is guy Jeff. He had a chemistry test, and there were 25 questions, and he answered them all. Okay? For every right answer he gets 4 points. And for each wrong answer he loses 2 points. If he got a score of 70 points, how many questions did he get right? So let's take a really quick little sidebar for a moment. And by the way, I want to go back to number 1 really quick. It's important that it says how many positive factors you have here. I forgot to mention that before. I was going to do the first thing I was going to say. That's not looking at negative factors. So technically you could argue there's 24. There's also mathematically arguments that factors always have to be positive. And negative factors are just the multiplication by -1. But in any event, it particularly spells out that it's positive factors. So on any other questions, where, because they may have given, instead of given A as 4, they may have given thrown out A and made it A, B, C, D. So D was 12 and F may have been 24. Because it says positive factors, it could never be 24. So some of this is English words and some of this is terminology on top of it, right? So you have to be able to weigh it as you're reading the questions. It's saying there's a bunch of factors and they're positive versus not being negative, okay? So let me just skip back to 3 again. So let's take a sidebar, which is that if I said I had 3 quarters and 2 dimes, you do that by doing 25 times 2 plus 3 times 10, and you get the number of cents. So you get 75, and then 20 cents is 95 cents. So this is going to work the same way. So the example of the thing would have been 25 times the number of quarters plus 10 cents the number of dimes equals what? So if I told you 3 quarters and 2 dimes, you could just fill that in. So this kind of thing is going to work that same way. So he got 4 points, okay, for each right answer. So I'm going to use the letter R to demonstrate or to symbolically represent right answers. And he got 4 wrong. For each wrong he loses 2 points, right? So that's going to be his score. Yeah, I'm not sure why that just came on the screen because I told it to turn off all notifications. But anyway, so for every right he gets 4, for every wrong he loses 2. And then it tells us his score is 70, okay? So how the heck can we use that? There's 2 unknowns and we don't know what to do. Well, we have something else in our pocket. We know that the number of right plus the number wrong is equal to 25. That's what sentence number 1 tells us, algebraically. He said he answered all the questions. And if there was 25, then the number of right questions plus the number of wrong questions is 25. So there's 2 ways to solve this at this point. One is to solve for R or W. So I can say R equals 25 minus W. Or W equals 25 minus R. And then go back to this equation here and substitute them into that. All right? So in that case, we would have, I'm going to do that over here, we would have, if I use the R one, I'm going to have 4 times 25 minus W minus 2W equals 70. Okay? And at that point, we're just down to algebra, and we can solve it. We get 100 minus 4W minus 2W equals 70. Okay? Then we get 100 minus 6W equals 70. Okay? And then we can flip things back and forth. We can bring the 70 over here. 30 equals 6W. And W equals 5. So the number of wrong he got was 5. So if he got 5 wrong, we can come back to the second equation and see that the number right would be equal to 20. Okay? Okay, it turns out there's a second way to do this, and I would suggest learning how to do both of these to double check it. What we want to do is take these 2 statements, even though they don't seem to be related. They are. They're indirectly related to each other in a weird way. So what we want to do is metabolize the 2 of them out. In this case, we metabolize the 2 of them out by doing this. There's a second way to metabolize them out, which is that we need to do something with one of these equations so we can throw away W or throw away R. Okay, and we need either add the 2 equations or we're going to subtract them. So the first thing I'm going to do is take this equation, the second one, and multiply the whole thing by 2. that means every term gets multiplied by 2. So we have 2r plus 2w equals 50. Okay, that means this is now gone. Okay, so since I have a minus 2w and a plus 2w, what I'm going to do is add the both of these equations. So that's 70 plus 50 is 120. That's equal to that. Minus 2 plus 2 cancels out. And I get 4r plus 2r, I get 6r. Okay, so now I have 6r equals 120. And therefore r equals 20. And in that case, we can feed it back into the original second equation. And w equals 5. And then we can take both of these and put them through both of the original equations. So 20 plus 5 is 25. And this is 4r, so r was 20. That's 80 minus 2 times 5 is 10. So 80 minus 10 is 70, and they both check out. Okay? So that's a doozy of a problem. If you never saw anything like this before, it's worth looking into it. This technique is using substitution, and this is simultaneous equations, basically. And they're really basically forms of a line being twisted up in various ways. So in this one, we notice, even though there's two symbols, as long as we have two equations, and sometimes there's even more variables involved. So in this case, we only had r and w. It could be something else. Like there's other tests where if you leave something blank, it's either worth no points, or if you leave something blank, it might be 1 point off. In fact, we discovered how BCA works that way. So you can actually use a technique like this to figure out what's a good way to weigh your choice once you find out how proficient you are in the math or not. Okay? So it's really cute. It's really interesting. I have some solutions to these on a whole bunch of other live streams. In fact, I just did a problem of the day. Let me pop that out here for you guys. I have what I call the problem of the day for the SHSAT. I'm going to post the link in here. I just did one recently that involves that. In fact, I did two of them. One involved drinks and popcorn, maybe, and the other, I can't remember what it was. But there was two problems of the day that used the same kind of technique. And you should do the same thing. Even though the video's there, it also links to a PDF with the solution. Just read the problem, try to figure it out, and then try to piece it together. You may not, some of you who never saw this, but you may not follow what I just did on either form. But as you get a little sense of it, and you do it a second time, and then when you finally do it a third time, it finally sinks in. And then not only will you know how to do it, but when you see a problem that's written this way, you're like, okay, that's the solution mechanism I should be using. That's the technique I want. Okay. So again, it's important because a lot of you guys never saw a problem like this before, or you're not going to see it until later in the year. You're not going to see it until after the test is given. And only maybe a few of you guys who might be on a math team or something like that have probably seen anything like this. By the way, you guys can email me any questions you have. You might be doing prep in class. You might be doing a tutor of your own, although I do tutoring, so I'd love for you guys to contact me and work with me. But in the event, if you're stumped for some reason, your tutor's horrible, or you're doing it solo through a book, or you're using the New Jersey State test as a guide or something, which I strongly recommend you do. If you're stuck in any problem, just email me, GregsTutoringNYC at gmail.com. Okay, number 4 is another weird one, and I actually don't like the problem because I think it's not perfectly worded. It has two problems, I believe. First of all, it kind of makes you have to understand what a military clock is. A lot of you hopefully have heard of military time, which goes to 2400. So basically, instead of saying it's like 2 o'clock in the afternoon, you would say it's 1400 hours. But that's not really the way the average person talks. And then on top of it, even though you might have heard of military time, what is a military clock? Okay, so they tend to be believing they're describing it to you. So I would think it's a round clock, and they're saying it's numbered 1 through 24. So I'm a little confused because if 1 starts here, is 24 also at that same thing, or is 24 at the next tick over? Okay, and I think BCA does something that a lot of tests don't. If you look at the answer choices here, it's like 3 or 4, 5 or 6. So it gives a little wiggle room in case there's some ambiguity, or sometimes they're just testing a concept and they kind of don't even really care what your answer is, as long as you're in the ballpark. And by the way, that's a premise of a lot of tests, that if you find you're getting into weird numbers or crazy numbers, or like really involved numbers with lots of decimal points, you are probably solving the problem incorrectly. Mostly they're trying to see if you can understand the question, and that your understanding of the math concepts on top of it, and that you're being creative and things like that. So normally a lot of these just come down to plain arithmetic. And that's where a lot of you guys make the errors, because a lot of you guys actually understand the concepts, but when you go to do something like a 2-digit multiplication, you goof up. If it said, like problem number 1 said include 1 and 72, there's a few of you who are going to put number 10. The 10 is the count. And just forget what the question said. It's always worth going back to this. This is a test. It's asking you something pretty specific. Okay? And then on test day itself, as I say for a lot of this, there's nothing like test day, where your adrenaline might be pumped up, you may have been late for the test, and so on. Okay, so you guys for this year are going to be taking it online, but you don't want to worry that your internet connection dropped, or a whole bunch of other things here. Howdy out there again. I see a bunch of people out there. So again, we're talking about BCA math here, but it applies to a lot of other different tests, some of the examples. In fact, the example I just did, which was number 3 or whatever, that applies to all the tests that are listed in the title of this. The ISEE, the SSAT, the SHSAT, even the PSAT, it can apply to as well. These are all common algebraic things that really are involved with high school math or introductory algebra, things like that. Okay, so going back to number 4, it's a little confusing, but here's how I would approach it. It's either 24 or 25, and the 24 either overlays the 1 or not. So I'm noticing there's about 25 pieces here, so I'm going to kind of just tick it off in 4s. So if 1 and 24 overlay, then if that's 1, then there's about 6 more. That's 7. That's about 13. Okay, and that's about 19, and that would give me 25. Which, if I do 24 plus 1, I would be at 25 there. So I'm the guy who's saying I don't know if there's actually a 24 they're talking about. Okay, which probably doesn't make sense, because if it's a 24-hour clock, what happens during this gap? Does it hit 24 and go right over to the 1? So it's unclear of that. So, and I'm not even saying I'm drawing the scale on top of my penmanship being horrible. Okay, so then it says, what number is directly across from 19? Well, it looks like if this is the center, that it's probably 7. And if I did a little off the scale, either 19 should be here or 19 should be there. So if it's going to center, it might be here. Okay, and if it's there, it's actually going to be 8 or whatever. So I think 8's pushing it. I don't think it could be 8, just based on the way my brain is topologically viewing this mythological clock. There's also a second problem with this problem, which it says, what is the number directly across? Okay, if I go through 19 through the center to 7, that's not necessarily directly across. That's going through the center. But if 19's up here, is directly across here, or is it directly across right like that? In other words, is it here? Is it actually number 6? Okay, and if we look at the answers, what question number is this? 4. 4 says it's B. So I think 5's pushing it. So they're indicating that you're going across. Okay, that seems to be the indication to me. The other is maybe 19 was here, and maybe it is going like that. Okay, so I don't like this question. I think it's too fuzzy. It's a little vague, and on top of it, you kind of have to understand military time, and it's maybe unfair. Maybe unfair to ask of you guys to be able to be proficient in something like that. So it's a little pushing it. Okay, all right. 5 deals with time. So as you can see, we're all over the place. We're factors. We're deep algebra, where we're doing time two different ways. In fact, the previous example is really a geometry problem, and a spatial one at that, the spatial math, right? We have math like algebra, we have arithmetic, we have geometry, we have trigonometry. There's also spatial math, which like if I throw a baseball against the window, you're mathematically figuring if the baseball is going to smash the window or not. Okay? There's also logical math, working through things logically and trying to figure them out. And there's other maths as well. All right? There's all these kind of different things. So number 5 is if a race began at 3:43 and ended at 5:27, over at what time? So again, I don't even like the way this is worded. That should have probably been 2 sentences. But remember, they're wording some of these purposely this way to kind of annoy you. Part of the purpose of some of these tests is rigor. BCA is a really great school with lots of challenges in it. And if you can't get through this test, you're not getting through 4 years of high school in a school like BCA. So you really want to be able to interpret and get through just the questions. Not that these are representative of 4 years of school, but if you're not able to interpret these questions at this level and be creative and intellectually understanding and thinking outside the box and all these kind of things like that, you're not going to make it through. All right? Which is why you're given a test like this. It's being demonstrative of various things. So here we're just going to take the 2 times. So we have 5:27. And I noticed they're both PM. So I'm not going to care about that at point. And we have 3:43 also PM. And we're going to subtract the 2 of these. Right? And then after we subtract them, we're not just going to be left with that. It says half over. Right? So whenever we get an answer, we have to feed it back into the question, then make sure we actually solved what they asked us to do, then make sure that we actually solved the problem completely. A lot of you guys, when there's a 2-part problem, you solve the first part, and then you just go to the next question. Even when you go to do your double checking. And by the way, I suggest that you actually do your double checking while you're actually doing a question. And do your double checking by using another technique, a second totally different technique to solve the same question, especially if you're apt to run out of time. Enough students never finish this test. Again, it's 40 questions that you have to answer in an hour. That's a lot of stuff. Something like question number 1, it looks so easy, and a lot of you can pound that out maybe in 20 seconds. But a few of you are going to forget some of the factors and actually get it wrong. Because one of the problems, let's say question number 3, the problem with the hard questions is they're hard. And I always say the problem with the easy questions is they're easy. So many of you get easy questions wrong. Okay? So part of this is about pacing yourself and being mathematically proficient and fluid. And on some questions, there's techniques. I think there's 1 or 2 in here that we didn't get to yet. That we're going to see that there's alternate ways to do it that is like lightning fast compared to the traditional way to do it. All right? So these are things you always want to worry about, be concerned about, and make it part of your mathematical toolkit. Right? Again, part of this is not just about solving raw math. It's about your mathematical prowess and how you're approaching problems with your numeracy and your fluidity. And you need to have things like no hesitation math. Right? So this technically, it almost looks like your NJSLAs, but it's not. There's a second level on top of some of these, especially that it's timed. So you need to be mathematically proficient enough to do it. Some tutors or books or whatever look at these kind of problems and say, oh, here's the trick to solve it. I don't think it's a trick. It's just math. If you're proficient enough in math to know how to solve it, then do it. It's not a trick. It's math. It's how to solve something mathematically. So again, I would use alternates for solving some of these problems in cases like that. So we have 527 minus 343. And by the way, make sure you copy your numbers down, write it wrong. Okay? So many kids make errors, they'll copy the number wrong. Whether it's part of a polynomial, whether it's the times, whether it's making a multiplication. Some people, even when you get a temporary value that you're going to use to do the second part of a problem, some you copy the temporary value wrong. And it kills all you guys. So your math is all right, but you're using the wrong numbers because you just copied it wrong. So anyway, we're going to do subtraction here. So 7 minus 3 is 4. Okay, we can't do the 2 minus 4. So normally you would borrow from the next column. So that's 4 and put your 1 there. Okay, but this isn't 12. You're borrowing 60 minutes. So this becomes 8. This is 20 already. So we get 8, you get 4, and then you get 1. So you have 1 minute and 54 seconds, right? Sorry, 1 hour and 54 seconds. Okay? So so now we need to divide this in 2. So this is 60 plus 44. So we get 104 divided by 2, we get 52 minutes. Okay, now we need to go back to the 3:43, because that's the start time, and add 52 minutes. So 3 plus 2 is 5. 5 plus 4 is 9. So that's 90 minutes, right? 90 minutes. So if we add a 1 to here, because that gives us 60, we're left with 30. And then we get 4:35. Okay, so the answer for 5 should be D. And it is, I just checked. All right. Again, Heidi out there, I see a few lurking. Please try to guess the answers yourself. You can post questions as I'm doing it, and I can do shout outs for you guys if you get it right. Okay. Number 6 is kind of easy peasy, but some of you again may not be aware of radicals and exponents and so on. So normally we have the square root of say 4 equals 2, right? Means 2 squared equals 4. Okay. So when it's a fraction, if I have the square root of x over y, this is the same as the square root of x over the square root of y. Okay. So the square root of 1/4 is the same as the square root of 1 over the square root of 4. The square root of 1 is 1, and the square root of 4 is 2. So we get a half. So that one was pretty straightforward. 6 is 8. All right, so be careful. Know your rules. This is indirectly related to exponents as well, because the square root is the same as the power of a half. So this could have also been rewritten as this. We could have had 1/4 to the 1/2, right? This means square root. So be careful, because they can change this up. Remember I said before, there's tens of thousands, even hundreds of thousands of possible questions they can ask you. They can take this square root of 1/4 thing and just make it 10 different examples, meaning the same thing. All right, so be careful, because it could have also been 1 over 2 squared to the 1/2, or the square root of 1 over 2 squared. It could be a whole bunch of stuff. It could be, the square root of 8 cubed, just a whole wacky stuff to get you where you need to be on some of these things. All right, so be careful with these. And by the way, some tests, that slash means divide, obviously. Some tests will make it like this, the 1/4 is, where it's 1 with the divide line and the 4 underneath it. So I think it should be clear to you guys what they're trying to do here, that's the same as 1/2. In some cases, they might write all the choices as decimals. In some other cases, they may have mixed numbers, which is a whole number and a fraction. Or in some cases, they might make it top-heavy fractions, where the numerators are greater than the denominators. In some cases, they might have fractions, mixed numbers, decimals, radicals, a whole bunches of places. Like powers of pi, 2 pi could be the answer. So it depends what they're looking for here. Okay, let me make sure we're still live. Yep, seems to be. All right, so I'm going to go. We're 36 minutes in, and we're about halfway through. So let's see how far we get. So which of the following fractions is equivalent to 1 1/4%? So when I say x percent, that's the same as saying x over 100. Okay? So therefore, 1 1/4% is equal to 1 1/4 over 100. So we could do a couple things here. We can convert this to 5/4. We could also convert it to 1.25. Okay? I prefer the decimal version, and I see, well, I don't like this. I don't like that there's either a fraction or a decimal here. So I notice I can multiply this by 4 to get 5, right? 4 times that, so I get 5, and if whatever I do to the numerator, I'm going to do to the denominator. So I get 400, right? And then you notice 5 goes into 40 8 times. So 5 goes into 400 800 times. 80 times. And that should be our answer. 7 should be C. Yep, it is. All right. Again, even if we kept it as this right here. So this is 5/4 divided by 100. All right. How do we get that into a fraction? Okay. The next one is a doozy. So I'm going to write those out. Let's see, what's the best way to do this? You know what? Let's use the test paper. That might be the simplest thing. Does that fit? What question is that? Number 8. Where's number 8? So the kind of way to do this is you have to convert them, probably all convert them to decimals. So 9 over 40 means 40 into 9. And since we know we're going to get decimals, we're going to put at least 2 of them here, right? So 40 goes into 90 twice, right? We get 80, and we get 10 left over. It goes into there twice, right? And we get another 0. We get 2 left over, and there'll be 5 there. So we get 0.225 for that. Okay? So if we do that for each one, and I did this beforehand. Let me see where I wrote those down. Yeah, so if we go through the problems, this was 0.225, okay? B was 0.3125. Okay, C is 0.28125. This we already know, okay? And this is 0.234375. So there's our numbers in front of us. Here, let me try to get this all on the camera. Does that fit? There we go. So now it's just a matter of saying which is closest to this. So this is 0.3 away. So let's use that as our target. Okay? 0.22 is even further away. Right? So actually that's a little closer. 0.31 is way too far. 0.28 was this? So that's further away than D. So now we have to compare these, and now we have 0.234. So 0.234 is closer to 0.25. So our answer there is E. Okay. The problem with this technique is that it takes way too much time. Way too much time. Okay? So let's look a little deeper at the numbers. So here's maybe a quicker way to do this. I noticed that 2.5 times 40 is 100. So I'm going to multiply the numerator and the denominator by 2.5. So 9 times 2.5, right, is 18 plus 4.5. So I'm going to get 22.5 over 100, which is what I got already. Okay? So what I'm doing is a quicker way of doing the division like this. I'm trying to make this faster, just by kind of using what I know. Okay? If I take this one, I notice that 16 times 9 is 96, right? So 9 times 5 is 45. Okay, so that number's too big, right? That was 30. What did I do? 16 times 6 I meant. I said times 9. Times 6, and this is 30. All right? This one, I notice if I do the denominator times 3, I get 96 again. So I get 27, right, over 96. So I have a few with 96s in them. Okay, this we know is 0.28, and this is 64. Okay, and this one I notice if I multiply the denominator by 1.5, I get the 96. 64 plus 32. So what I'm going to do is multiply 15 by 1.5. So I'm going to add 7.5. So I get what, 22.5 is that? Yeah. And now I can compare the numbers again. Realizing that for a few of them, I'm under because my denominators are 96, which means the numerator should be slightly higher. When I do that, I still get E. I'm left between C and E again. Okay? And maybe at that point, I could do the long division for those. Okay? But there's still another way to solve this problem. Okay? I don't know if anybody can see it. So if you stare at the numbers a little deeper, let's take E for a second. 16/64 is a quarter, right? 8/32 is a quarter, right? 4/16 is a quarter, and then 10/40 is a quarter. So we're one off of the denominator. So in the case of 40, the 9/40 A, we're 1/40th off from being a quarter. In the case of B, we're 1/4 off from being a quarter. In the case of C, we're 1/4 off being a quarter. In the case of E, we're 1/4 off being a quarter. Now we all know that if we have 1 over something, the larger that something is, the smaller the number is. In other words, 1/2 versus 1/millionth. 1/millionth is definitely smaller. So what we want to do is pick the largest denominator that's 1 off from a quarter. And that turns out to be E. Because 1/64 is the smallest movement away from 0.25. Now, there's one anomaly with this example, which is that choice number D is already a decimal. So it's 0.03 away. Right? It's 0.03 away. So we have to figure out, is 1/64 further away or not? And it turns out that 0.03 is further away. So there's still a little work here that needs to be done, but you could almost solve this. 8 just comes down to D versus E, right? When we went to longhand, the longhand division, it became down to C versus E. And when we used my kind of shortcut longhand, it also came down to C versus E. But if you look at the problem logically first and understand that each one is off by its 1 over its denominator from a quarter, we realize it just comes down to that E has to be the answer. And then we only need to decide whether it's 0.28, which is already in decimal form, whether that's true or not. Okay? We could have also converted 0.28 into a fraction, right? 0.28 over 100, something like that. And then made versus that versus a quarter, right? 0.28 over 100 is 0.03 more. So we can kind of work with that, right? So 8. So far we had, there's a lot of easy ones. Number 3 was a doozy. Number 8 is not so much that 8 is hard to do. I think you can all do it. The question is, can you do it in 30 seconds, right? So you need to have that insight. To some of these, there's always going to be that little gotcha on some of them, where you have to go that extra, like, oh, wait a second. And sometimes that's going to happen. It's going to just totally leap out at you. Like, this looks like a complicated problem. Let me see if I can do it. This one doesn't look complicated. But once you start saying to yourself, wait, they're going to make me spend all the time doing the long division, the denominator into the numerator for every single one of these. Now, on some examples, they will make you do that. But the chances that, like I said earlier, they're normally just testing whether you understand the concept and whether you can do the arithmetic. So they don't really make a lot of it hard math. It's not really deep multiplications, deep divisions, things with zillions of decimal points. That's not what they're shooting for here. Normally things cancel out, or normally something happens. In this case, nothing canceled out, but something did happen. What happened, it was 1 over the denominator away from a quarter. All right? So you need to sometimes, instead of spending 2, 3, 4 minutes and making a mistake. So what's going to happen is if you divided just A, B, C, and E, its denominator into its numerator, enough of you are going to make a mistake in those simple divisions. And obviously get the wrong answer, and maybe even have to start the problem over again. So when you start saying, oh, they're going to make me kind of sweat through this one, even if it's easy, this is just grade 3 division, right? But there's going to be silly errors. The test is kicking off. You might not feel well that day. 1,000 things. Just give your brain the 2 extra seconds to like, is there another way to do this? Once you ask yourself that question, you'll often find, oh, there's some pattern here, right? Because 8 is really a pattern question on top of everything else. So you guys got to be careful with some of that. All right, how we doing on time? We have about 10 minutes left. Maybe we won't finish today, but at least let's practice this. Number 1. Okay, so the next question is also an algebra-based question. It's actually fairly easy. In this case, the English maps directly into the math. So there's an advertisement that says buy 3 tires at a regular price and buy a 4th tire for only $3. Carol paid $240 for a set of 4 tires. What is the regular price of a tire? You know, you can kind of sit there and kind of twiddle your thumbs and make some guesses on it. For instance, if there's 4 tires, you know that there may be $60 each. So enough of you who don't know how to solve this might really be apt to choose choice number A. All right? And then on the flip side, because the $3 tire, right, the 4th tire is only $3, you might say, well, I'll do 240 divided by 3 and get 80. So, and from that note, some of you might pick E and then say, well, there was the $3 one, and then go to 79. Okay? But I believe all those choices are wrong. So let's just map it directly. We have 3 times the price of a tire plus the 4th tire at $3 equals $240. And that's it. That's your algebraic statement. 3 tires at some price plus $3 equals $240. And we're looking for the regular price, which is P. So let's just subtract 3 from both sides. We get 3P equals 237. Right? And then we're going to divide both sides by 3. So we get 7 times 3 is 21, 2. 3 goes into 27, 9, and we get $79. So 9 had better be D. Yep, it is. Okay. 10 is a doozy of a problem. A doozy, doozy, doozy. So what I might do is hold off on 10, and maybe we can get through the others if there's enough time. And maybe I can do a live stream after we do a few, maybe practice test 2 and practice test 3, and maybe do kind of like the hardest BCA problems there are. So 10, just to give you a little hint, the issue with 10 is you can all do 199 times 19.9, but it's error prone, it's tedious, and it's going to take you too much time, especially if it's error prone and tedious. And just like the question over here, where you're going to do those long divisions wrong, enough you're going to do the multi-digit multiplication wrong and get the wrong answer that way. So there's a way to get around this that takes a few seconds. So that's just a hint. So, and of course the long division, long multiplication is the way to include it. So 11 is a classic standardized test kind of a question, and it's multi-part problem, multi-part word problem. So what we're going to do is take it in parts. So we have the average of 6 numbers is 4. A 7th number is added, and new average is 5. What is the 7th number? All right, so this is standard, standard, standard. And again, they twist it 10 different ways. So normally to get the average of something, it's the sum of the numbers over the number of numbers. Okay? So they're giving us some of this information. They're telling us that we have 6 numbers, the sum of 6 numbers over 6, right, equals 4. right? The sum of 6 numbers over 6 equals 4, because that's how the average works. So therefore, that means, this little thing here means therefore, that the sum of the 6 numbers equals 4 times 6. So we just use algebra, so it's equal to 24. Okay? So that's the sum of the first 6 numbers. A 7th number is added. Okay? We don't know what it is. So it's telling us a 7th number is added. So we have this 24 as the sum of the 6 numbers plus the 7th number. So if we're going to get the average of that, we're going to divide it by 7. They're telling us that's 5. So we're going to go backwards the same way. Multiply both sides by 7, that cancels. That becomes 35. And then we subtract 24 from both sides. We get 11. And 11 is 11. D. All right? So this one is a standard test pattern question. I don't mean it's a pattern. It means this comes up on a lot of tests. So that's something you should be aware of. Okay. The next question is one of those questions that is so easy that enough kids get it wrong. So the pharaoh was born 4,300 years ago. Approximate when did his 12th birthday occur? All right. So if he was born 4,300 years ago, okay, and today is 2020, right? We can do that subtraction and get something there. What I'm going to do is, if I look at the answers, they all look like they just rounded off. So we actually don't have to literally do the subtraction. And even if we did it, it's 2020. This sample may have been on here for a dozen years. You know, BCA may have had this sample test on their site for a dozen years. So next year, the same question 12 is going to be there. And it says, it's talking about the pharaoh's 12th birthday. So how about we just get rid of the 2020? All right, so we have 4,300. This minus 2,000. So we get 0032. And we get 2,300. And 12 is 8. It's just that simple. There's nothing else here. A lot of you are going to go minus 4,300 and notice that it should be minus 4,312, you think? And then say, well, G is the best answer because this is approximately. Right? Here. BC. Right? There's year 0. From year 0 to 2020. So you have to go backwards from 0 backwards. And that gets you to about minus 2,300. So be careful. We normally don't deal with BC dates, but that's one of the issues there as well. On that same note, 13 kind of has some similar issues there. It's saying we're losing connection. I'm not sure if the stream is still live. Give me 1 second. Yeah, so you know what? If we're not live, you're not seeing this. And if we are live, it's telling me something's wrong. So here we are. We're at the hour point. How about we stop here then? And because I'm just talking into the ether, that doesn't make sense. And we went for an hour. And like I said, I'll continue this. I originally said I'll do one of the practice tests a week, but since there's a part 2 to this, maybe I'll stick a part 2 in over the weekend or some other day. All right. So if I'm still live, hopefully everybody's going all right. If I'm not live anymore, well, I'm talking to nobody. So let me end the stream. Peace out. And again, guys, email me with any questions. Bye. It's not even letting me terminate this. I don't know if it's dead yet.